Advanced Algebra Chapter 13, Lesson 3, and we've looked at converting degree measurements into radian measurements, and we want to look at how we can use those now to create what we call reference triangles, and then be able to give the sine and cosine of any angle that's given to us. So what I want to concentrate on are the radian angle measures, because these are going to be very important in the future. So just as a reminder, some things that should help you, or that may help you, remember at least the measure of these central angles that we'll be looking at. You remember anything that has a denominator of 2, or a multiple of 2, or even a denominator of 1. Meaning if you have something like just pi over 1, these are what we are going to call, or what are called, quadrantal angles. And quadrantal angles are angles where the terminal side ends up on one of the x or y axes, either positive x, positive y, negative x, negative y. So the terminal side actually ends up on the axis, and we'll take a look at those. So anything that has a denominator of 2 or a denominator of 1 is a quadrantal angle, and how we handle those is just a little bit different than how we would handle other angles. Anything that has a denominator of 3, then the central angle is a 60-degree angle, or a multiple of that. So anytime I see a denominator of 3, I know that the central angle that we'll be using for our reference triangle will be a 60. If we have a denominator of 6, we know then that the central angle is going to be a 30-degree angle, or multiple thereof. And if we have a denominator of 4, it's going to be a 45-degree angle. And once we know what these central angles are, we know what kind of triangle we have, we can then use the relationships of the 30-60-90 and the 45-45-90 to determine the sine and cosine of these angles. And the reason that we can do this is because any angle that is coterminal with any of these, the sines and cosines of those angles are exactly the same. So we really don't need to know the sine and cosine of a 540-degree angle. We just need to know the sine and cosine of any angle that's coterminal with that. And if it's a 30, 60, 45, 45, 90, or a 90-degree angle, then the sine and cosines are going to be the same, so we're going to use these as our reference. So taking a look at number 1 here, what we want to do is, once we have the terminal side drawn, and in these first examples they already drew it for me, in the coming examples we'll have to figure that out for ourselves. But the first thing we want to do is always draw a vertical line to the x-axis, creating a triangle. So this creates that triangle. And it's important that you always go to the x-axis, always go vertical line, never draw horizontal. That's going to throw your trigonometric angle off. This creates a triangle. And so what I would like to know would be the lengths of the sides, because then I can use my sine ratio, opposite over hypotenuse, or my cosine ratio, adjacent over hypotenuse, to determine the values. Well, in this case, all I have to do is look at the denominator. Because the denominator is a 4, I know that this central angle is a 45 angle. So this is a 45, 45, 90. Now all I have to do is label my sides. I know the sides are equal, so I'll call them both 1. We do have to keep track of our signs here. So the x value goes to the right, so that's positive. The y value, however, goes down, so that's a negative 1. And then the hypotenuse is square root of 2. Now I can go ahead and use this reference triangle to determine the cosine of this angle. Even though it's not a 45, it's a negative 9 pi over 4 angle, which is more than 405 angle, but we can use this as our reference. The cosine ratio is the adjacent side over the hypotenuse, so we take the adjacent side here, which is 1, over the hypotenuse, square root of 2, and we have our cosine ratio. So the cosine of this negative 9 pi over 4 angle is 1 over the square root of 2, which is also the cosine of a negative 45-degree angle. And again, because they share this side, or they're coterminal, the cosine is the same for both. So the process for doing this simply is to create a reference triangle, determine the measure of the central angle, and then use the ratios that you know from those special triangles to determine the value of the trig function. Taking a look at number 2, again, because it's already drawn for me, all I have to do is draw the triangle and figure out the measure of this angle. And to do that, all I have to do is look at the denominator. The denominator is 6, so I know that this angle is a 30. So this is a 30, 60, 90 triangle. Opposite the 30 is 1, and because it's down, it's negative. Next to the 30, this is the longer side, so that's square root of 3, and the hypotenuse is 2. And then the sine is the opposite side, negative 1 over the hypotenuse 2, so the sine of this angle is negative 1/2. So we're going to draw reference triangles and use those to determine the ratios. I'm going to do one more where we have the drawings for us, and then we'll look at how do we do it when we have to make up the drawings for ourselves. As I look at number 4 here, again, the terminal side's already drawn for me, so I can draw my triangle. All I need to do then is to figure out what the measure of this angle is. Because the denominator is a 3, I know that this is a 60. And because this is a 60, opposite the 60 is the longer side, so it's radical 3. But because it goes down, it's negative. This would be a 1, but because it goes left, it's negative. And then the hypotenuse is 2. And now I can figure or determine my ratio. Cosine is adjacent, which is negative 1 over hypotenuse, which is 2. So the cosine of this angle would be negative 1/2. So what do we do if we're given the angle, but we're not given the drawing? So that means we're simply going to have to draw this for ourselves. So let's take a look at how we can do this. Now, a couple of things to remember. If it's a positive sign, we're going to rotate counterclockwise. Okay, so this would be a positive rotation. If it's a negative sign, it's going to be a negative clockwise rotation. And then we're going to look at the denominator to help us know what kind of angle it is. It's just a matter of where does this angle end up. Now, what I like to do with these, what helps me is I look at the denominator, and that tells me what kind of angle I have. So a pi over 3 angle is a 60. Now, so I know that this angle is a multiple of 60. The number in front in the numerator tells me how many angles or how many 60-degree angles I have. I have 17 60-degree angles if I break this apart. And I know that I'm going to rotate in the clockwise direction. So all I have to do is, starting at the positive x-axis, count this way 17 60-degree angles. Now you can count by 60s if you want, but there's a little bit quicker way to do that, and that is to take a look at what does pi over 3 mean. Well, that means take pi and divide it into 3 equal parts. That's what the denominator tells me. Well, if I think about pi being half a circle, which we talked about earlier, then half a circle is divided into 3 parts. So if I go half a circle, that's 3 60-degree angles. And if I go another half a circle, that's 3 more. And another half a circle, that's 3 more. And another half a circle, 3 more. So every time I go half a circle, I'm going 3 60-degree angles. And if that makes sense, if you take 60 multiplied by 3, it's 180, half a circle. So putting all that together then, I know I have a multiple of 60. I need 17 of them going in a clockwise direction, and there's 3 in half a circle. So I'm going to count by 3s until I get to 17. So here's 3, 6, 9, 12, 15, and then 18 would be all the way around to half a circle. I need a 17, so I'm 1 short of 18. So that means this angle is going to be right here. So I can create my triangle or figure out where this terminal side is using that method. And I already know that this is a 60 because I determined that before I started. So now all I have to do is label my sides. So opposite the 60 is square root of 3, and it's up, so it's positive. This side is a 1, and it's to the right, so it's also positive, and this is a 2. So now all I have to do is write my ratio, and we're looking for the sine of this angle. The sine is the opposite side, radical 3, over the hypotenuse of 2. So the sine of a negative 17 pi over 3 angle is radical 3 over 2. So a few things you can use to break it down. Use this to figure out what kind of angle you're going to have, a 30, a 60, or a 45, or a 45, excuse me. The number in the numerator tells me how many of those angles that I'm going to have. The sign in front tells me if I'm going to rotate clockwise or counterclockwise. And then all I have to do is remember that there's this many of these angles, whatever they are, in half a circle, and I just count how many I need in the direction that I need to go. So I know that's a lot of information on one problem. Let's do a few more examples, and maybe that'll help us out a little bit. I'm going to go down here where we see the answers just so we can double check ourselves here. So what would be a sine of negative 7 pi over 6? Well, pi over 6 tells me that's a 30-degree angle, and there are 6 of them in half a circle, and I need 7 of them going in the clockwise direction. So starting at the x-axis, half a circle is 6. I have 7, so that's 1 more. So there's my reference triangle. I already know that it's a 30. Opposite the 30 is a 1, and it's up, so positive. This side would be radical 3, and because it's left, it's negative, and then this is 2. So I have my reference triangle, and then I simply use the sine. The sine is the opposite side, which in this case is a 1, over the hypotenuse of 2. So the sine of this angle is a half. Okay, let's look at 19 pi over 4. Negative. The pi over 4 tells me it's a 45, 45, 90, and there are 4 of them in half a circle. I need 19 of them, and I'm going to go in the clockwise direction. So half a circle is 4, 8, 12, 16, and then 20 would be to here. I only need 19, so I'm 1 short of 20. So that means my triangle is going to be in this quadrant here. And I know it's a 45. So this is a 1 and it's down, so it's negative. This is a 1 and it's left, so it's negative. And this is square root of 2. Then I simply need to do the cosine. The cosine is the adjacent side here, which is negative 1, over the hypotenuse, square root of 2. And then rationalizing my denominator, I get square root of 2 over 2 as my cosine. Let's do one more, and then we'll look at quadrantal angles real quickly. If we're looking down here at number 10, we have 17 pi over 4. Again, the pi over 4 tells me it's a 45, 45, 90, and there are 4 of them in half a circle. I need 17 of them, and I'm going to go counterclockwise because it's positive. So half a circle is 4, another half is 8, 12, 16, and I need 17, which is 1 more. So my angle is in this quadrant, and I know it's 45. Positive 1 here, positive 1 here, and radical 2. And so the sine is the opposite over the hypotenuse. Rationalize my denominator, and I have a square root of 2 over 2. So that's how you draw a reference triangle using the 30, 60, 90, or your knowledge of a 30, 60, 90 and a 45, 45, 90. In the next video, I'm going to take an exclusive look at quadrantal angles and how we handle those.